Hello everyone, welcome to my channel GenAI LLM and the Research. So today we are going to understand some of the important topics in LLM like context window, what is context window, what is pre-training objective, fine tuning, what is out of vocabulary and embedding layers. But we will focus today on context window and pre-training objective. So hello everyone, happy learning. Please like and subscribe my channel to bring up this kind of educational videos. So what is this windows? So let us start with understanding the context window. The context window in a large language model refers to the maximum amount of text or tokens the model can consider at one time when generating a response. It determines how much prior conversation, document content, or code the model can remember before responding. It is basically the capability of the model to remember the previous chats or previous document content, etc. For example, if an LLM has a context window of 4096 token, it can process up to 4096 tokens that includes words, punctuations, and spaces at once. If the input exceeds these limits, older tokens are discarded or truncated, which means the model might lose the earlier parts of the conversation or documents. It just remember only within 4096 tokens. Example scenarios like chatbot with a limited context window. Scenario 1. The short context window. Suppose it has a context window of 512 tokens. So a user is chatting with a customer support AI about an issue with their internet connection. So here it is, like user is saying, "Hi, my internet is not working." AI is responding, "I am sorry to hear that. Have you tried restarting your router?" The user saying, "Yes, but it still does not work." AI says, "Okay, are you using a wired or a wireless connection?" User says, "Wireless." It keeps disconnecting every few minutes. So AI says, "I understand. Let me check for the network issue in your area." So it is within that 512 tokens, so it's responding in a better way. Scenario 2, where it's a longer context window. Suppose there is a longer context window of 8192 tokens. Now, with a larger context window, the AI retains the entire conversation history. This allows it to remember the past details, like the user is on the Wi-Fi and has restarted the router already to resolve this issue. Avoid repeating questions, like does not ask again and again, it's a wired or wireless. It provides better troubleshooting. It might not suggest checking the Wi-Fi interference, etc. So this is basically the context window. So the amount of tokens, maximum token will be there. The LLM model will have the ability to remember more conversation and it gives more precise answers and stop repeating the same thing. Now we will learn about what are pre-training objectives. Pre-training is the first stage in developing a large language model, where the model learns general language pattern from massive dataset before being fine-tuned for a specific task. The pre-training objective defines a specific task the model performs while learning from the data. Okay. The most common type of pre-training objective in LLMs are casual language modeling and masked language modeling. We will go through that with example so that it will be easier for you to understand. So let us see what is this casual language modeling. That is called CLM, next word prediction. In casual language modeling, the model is trained to predict the next word in a sequence given the previous words. This is commonly used in the autoregressive models like GPT-4, GPT-3, and Llama. Let us see how it works. The model receives a sequence of words and learns to predict the next word step by step. The training data consists of large amount of text of books, articles, and websites. For example, input is the cat sat on the. Okay, so the expected output would be the mat. So if the model predicts a table instead of math, it receives a loss penalty and its weights are adjusted to improve the future prediction. Over time, the model learns grammar, syntax, and factual information from the training data. The advantages of CLM: it works well for the text generations like chatbots, creative writing, etc. Produce coherent following text that follows the natural language patterns used in models like GPT-4, GPT-3, and Llama. Limitations are it cannot fully understand the missing words in the middle of the sentences. For that, we have a different method. It struggles with the bidirectional context, which can limit comprehensions in some cases. To overcome the previous issue, there is a concept comes of masked language modeling, that is MLM, that is basically fill in the blank prediction. So in masked language modeling, the model is trained by removing or masking some words in a sentences and asking the model to predict that particular masked word. This is used in bidirectional models like BERT, that is bidirectional encoded representation from transformers. How it works? A portion of a sentence is masked, that is hidden. The model learns from the to predict the missing words using surrounding words, both before and after the masked token. That's why it's called bidirectional. For example, the cat sat on and then the word is mask. The expected output is mat. So unlike CLM, MLM allows the model to learn from both left and right context, improving its ability to understand the sentence meaning. Let us see what are the advantages. It is good or excellent for understanding meanings and relationships between the words. It improves performance in question answerings, search engines, and text classifications used in models like BERT, Robert, and Roberta and T5. The limitations are not ideal for the free text generation since it is not predict text sequentially and computationally expensive because it considers bidirectional context. The third we see is other pre-training objectives, that is denoising autoencoding, that is used in T5 or BART. The model is trained to reconstruct a sentence from the corrupted versions. For example, the input is the CTST on ET mat. Okay, the expected output is the cat sat on the mat. So this is basically denoise the auto encodings. Contrastive learnings used in CLIP, that is retrieval based models. The model learn by differentiating between correct and incorrect responses. Examples: a model might learn that Paris is the capital of France is correct, while Paris is the capital of Germany is incorrect. Okay, so conclusion is pre-training objective defines how LLM learn languages before being fine-tuned on a specific task. Casual language modeling is best for text generations. Masked language modeling is better for understanding and classifying text. And other objectives like denoising, autoencoding, and contrastive learnings enhance the model's versatility, and these techniques power modern AI systems used in chatbots, search engines, and document processing. Thank you, guys. So this was at this moment, and we will go through all these important things again in next video. So thanks and happy learning. Please like and subscribe my channel.